Hello dear KCET aspirants, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we will be doing the top 30 previous year questions from the chapter Amines. Okay, so I have taken the top 30 questions from 2014 to 2024. All type of questions that have been asked is considered here. So please now sit with the notebook and pen and then watch this video and try to answer the questions first. And if you are not able to solve it, then see the solution. Okay, so you need to play the video, see the question, write your answer and then check the answer. If you are getting wrong, then please understand the solution and mark that particular question. Okay, so you will be getting the PDF of these questions in our WhatsApp channel. The link of the WhatsApp channel will be there in the description section, so you can just download it and then you can practice this and then you can use it as a test as well. Okay, so yes, now let's get started with the first question. That is, this question has been like a secondary amine is a very basic and fundamental question. So this question was asked in 2022. Okay, so what is a secondary amine? So I can say this question is super easy on the structure, so it should not take more than 30 seconds to solve this question. So the options here, let us first understand what is amines, right? So first is amines are derivatives of, okay, amines are derivatives of ammonia. Right, amines are derivatives of ammonia. Ammonia has 3 hydrogen. Now you replace 1 hydrogen with an organic compound, then it is called primary amine. If you replace 2 hydrogens with an organic compound, it is called secondary amine. And if you remove all the 3 hydrogens and replace them with organic groups, that is called tertiary amines. Right, so secondary amine structure should be N. I should replace 2H with R groups. R means your organic groups. Okay, so you can see a compound with an NH2 group on the carbon atom in the second position. No, the NH2 group should not be there. A compound in which 2 of the hydrogen of the ammonia have been replaced by the organic group. Yes, this is the correct option, that is option number B here. Question number 2. The method by which aniline cannot be prepared is. So this is your methods of preparation. Aniline is what? The structure of aniline is like this, right? Aromatic amine, you can say. This is aniline, and this question was asked in 2021. This is also very easy question. Nitration of the benzene followed by reduction of SnHCl and concentrated HCl. This is your stiffened reduction, and by this we can synthesize aniline, right? We can do degradation of benzamide with bromine in alkaline solution. So this is your Hofmann bromamide reaction, and with this also we can react the or we can produce aniline. Next, reduction of nitrobenzene with H2 and palladium. Yes, this is also possible. Next, potassium salt of phthalimide heated with chlorobenzene followed by the hydrolysis with aqueous NaOH solution. So this is actually Gabriel phthalimide synthesis, but in Gabriel phthalimide synthesis you should always remember here it should be a primary amine. Okay, it should be a primary haloalkane, primary haloalkane. Okay, but when you take chlorobenzene, it becomes a secondary haloalkane, so that is why this is not the correct way. So the correct answer for this question will be option number D. Next question, which of the following has the lowest boiling point? So 2020 question on the physical properties, super easy question. So whenever boiling point or melting point is asked, okay, boiling point or melting point is asked, then what is the basis? What decides the boiling point and melting point? It is the intermolecular forces. Okay, intermolecular forces. Now when we talk about intermolecular forces, we generally talk about hydrogen bonding. Okay, so one second, yeah, we talk about hydrogen bonding. Okay, now if more is hydrogen bond, more will be intermolecular force, more will be the boiling point and melting point. So now if you see here, hydrogen is there. So what is the condition for hydrogen bonding? Hydrogen should be attached to oxygen or hydrogen should be attached to nitrogen. Okay, now in this case, if you see here, there can be hydrogen bonding, here also there is hydrogen bonding, here also there is hydrogen bonding. But in option number B, which is the ether functional group, there is no hydrogen bonding. So the boiling point, intermolecular forces will be low. So boiling point and melting point will be low. So correct answer will be option number B here. Okay. Next, which of the following is least soluble in water? Now when we talk about solubility, okay, so this question was asked in 2019. Okay, this is also easy question, physical properties, some basic concepts about solubility you should know. Now when we talk about solubility, here also two factors are affected. One is your hydrogen bonding, okay, hydrogen bond is affecting the solubility. If we have more hydrogen bond, then it will be more soluble. Another is size, okay, if hydrogen bond is more, okay, solubility will be more. If size is less, then solubility will be more, okay. Now if you see out of all this, C6NH5NH2, this is the biggest molecule out of this 4 option. Its size is very big, that means its solubility will be less. So the correct answer here will be option number D, okay. Next, coming to chemical reactions questions, we'll see. Identify A, B, C. So this is 2023 question. Chemical reactions, easy question, but I can say where you can do mistake with the reaction due to HNO2. I'll tell what is the condition here. Now first of all, if you treat with KCN, so Br will be replaced with Cn, right? This is your A, and you can see option, this is NC. So for NC what we need, please comment down. If I want to add NC here, then what reagent I need to use? Now only you need to comment down this, okay. So we'll get this is as A, so we can eliminate option number B. Then lithium aluminium hydride, it is a reducing agent, right? So what it will do, CH2NH2, right? So B is CH3 CH2, then again CH2, and then NH2, right? So now if you see, here we have that one, and here we have something like that, but here one carbon is less, so we can eliminate this option and we can eliminate this option because here it is alcohol. So definitely answer has to be option number A. But what is the mistake that you can do of HNO2? So now here you have to remember something about HNO2, okay. First of all, HNO2 can be written like this. First point what I am saying, HNO2 is also equal to, if you write NaNO2 and HCl. You should not be confused whether it is what new reagent is given, right? Both of them are same thing. Now second point that you need to remember is, if it is an aliphatic, okay, aliphatic amines, one second, yeah, if you have aliphatic amines, then it will give you alcohols, okay. See, like we have here aliphatic amines, so with NH2 it gave us alcohol group. But if it is aromatic, if I have aromatic NH2, means your aniline, okay, then if you treat it with HNO2, then we will get benzene diazonium chloride, right? This will be the product. So that is why that thing you should know, and the correct answer will be option number A. Next, question number 5, aniline does not undergo, 2023 question, again based on chemical reactions. This is also very easy question, should not be there any mistake should be there. It does not undergo Friedel-Crafts reaction, okay. You know why the reason? See, if we have aniline like this, okay, for Friedel-Crafts reaction what I need like for example CH3Cl in presence of AlCl3, okay. So these two, what is the role of these two? They generate the electrophile. What happens? This AlCl3 takes one of the chlorine, and I get like this CH3 plus and AlCl4 minus. This should be produced. Now what happens if this NH2 is there? What it will do? This is acting as a base and this is acting as an acid, Lewis acid. So these two will react, as a result of which there is no generation of electrophile, okay. So that is why Friedel-Crafts reaction cannot happen in case of anilines, okay. Next, question number 7, again reaction based question, 2023 question, and this is a easy question, okay. So first of all, NH2PN2 plus Cl minus, just now I told you we need to give here, if aromatic amines are there, then we need to give HNO2 to give benzene diazonium chloride. But that is what I am saying, HNO2 can be written as NaNO2 and dilute HCl, okay. Concentrated HCl is wrong, so we can eliminate this option. Other NaNO3 is not correct, so we can eliminate this option as well. Next, you need to add what? next we need to add BF4. Okay, so for adding BF4 we need HBF4. F2 will not work, so that is why here also BF3 will not work, so we can eliminate this option. So we need so what happens now, you can see if I add HBF4 here. Okay, so now you see H plus is there and BF4 minus is there, N2 plus is there, so what will happen, this 2 will come and this 2 will come, so I'll get N2 plus and BF4 minus. Then if you treat it with copper NaNO2, then this whole group will go and we'll get NO2 group here. Okay, so that is what is this reaction. Correct answer is option number A. Next, question number 8, in carbyl amine test. Okay, carbyl amine test for primary amines, the resulting foul smell product is. So 2022 question. Okay, this is also very easy question, you should know. It forms isocyanate. The foul smell is due to the formation of isocyanate. So correct answer is option number A. Okay. Next, question number 9, C6H5CH2Cl with ammonia A and then again B is formed. So product B. So this question was asked in 2021. This is also very easy question, chemical reaction based question. 30 seconds is more than enough for this question. But yes, common mistake can be there in the IUPAC part if you know how to name it correctly or not. So first of all, what happens, how this reaction works, when you react any X with NH3. Okay, for first thing what happens, we get R. Okay, this this one of the H is replaced with R, so I'll get NHR. Okay, NH2R. Okay, now here one H and here one X is there, so that will form HX. Right, now again if I react it with NH3, what will happen? Again if I react another again if I react it with RX, again if I react with RX. Okay, so what will happen, another H will be replaced, so I'll get NH, R and R. Now again if you react it with RX, then all the H will be replaced and I'll get NR3. Right, that is what the product will form. So now we can apply the same concept to the question and see what product we are getting, and the most important thing is to write the IUPAC name correctly. Okay, fine. So let us first do C6H5CH2Cl is treated with NH3. What will happen? One of the H will be replaced with this R group. So I will get NH2CH2C6H5. Okay. Now again if you react, we have two methyl groups. So two hydrogens will be replaced with CH3 group. So what will I get? I'll get N. Okay, CH3, CH3, CH2, C6H5. Okay, now this is which degree amines? This is a tertiary amine, because you see all the hydrogens of nitrogen is replaced, right? So this is a tertiary amine. Now if I want to write it, the name, so it will be NN-dimethyl, 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 N-benzyl, N-phenyl, so these are wrong. Now NN-dimethyl, this is what? This is phenyl methanamine. Okay, so we will get phenyl methanamine. So correct answer is option number A here. Okay. Next, 10th question. Hydrocarbon A, C4H8 on reaction with HCl gives a compound B, C4H9Cl, which on reaction with 1 mole of NH3 gives compound C. On reacting with NaNO2 and HCl followed by treatment with water, compound C yields an optically active compound D. The compound D is. So 2021 question. Okay, so this is also easy to moderate question. See, the question here seems very lengthy, but these reactions are very basic reactions have been taken. So I don't think this question should be difficult, but let us start with this. So C4H8. So by seeing this, you can see it is a formula of an alkene, right? C4H8, one alkene is present. So first we'll write A is there, okay, which is C4H8. It is reacting with HCl, okay, to give you B, which is C4H9Cl. Okay, next, which on reaction with 1 mole of NH3. Okay, so ammonolysis gives a compound that is C, that is C4H11 and N. Okay, Now on reacting with NaNO2 and HCl, so I can write this as HNO2, okay, followed by treatment with water, compound C yields an optically active compound D. So first of all, you should be knowing when we treat HNO2, we will either get alcohols or benzene diazonoyum chloride. Now because this is an aliphatic amine, for benzene we need at least 6 carbon, so this must be, so because it is an aliphatic amine, so D must be what? D must be alcohol. Okay, so from that we can easily solve the question. You can see there is only one option with alcohol group and there is no other option with alcohol group. So answer has to be option number B, right? See how easily we could solve it. But yes, do not worry, I'll tell you the whole reaction as well. So first of all, it is C4H8 and then treating with this one is giving you this compound. So we can think that A can be like this, CH3, CH2, CH double bond CH2. Okay, now what happens? You treat it with HCl, so what will happen? There will be Markovnikov's rule, so one H and Cl will be added. So Cl will be added here and H will be added here. Okay, next what we did, it was treated with ammonia. So if it is treated with ammonia, what will happen? One of the H will be replaced here, right? So I will get here NH2. Right, so here I will be getting NH2. Okay, one of the H has been replaced with this whole alkyl group, NH2 I got. Then this part is converted to again what? If you treat it with HNO2, we will get OH. Okay, so that is what we got, CH3, CHOH, CH2, CH3, because it is also optically active because all the 4 groups attached to the carbon are different. Okay. Next, question number 11. So it's a reaction based question. Again, this is a moderate level question. Reagent should not be confused. Question was asked in the year 2020. I'll say moderate question. So first of all, NO2 to Br2 Fe Br3. So what it will give you? It will give you NO2 group is a, here you should know NO2 group is a electron withdrawing group. If it is a electron withdrawing group, it is meta directing group. Right, so NO2 will be attached at what position? At, sorry, Br will be attached at this position. Next, SnHCl, and this is your Stefan reduction. So what does Stefan reduction do? Removes NO2 to make it NH2. Okay, then NaNO2 HCl, that will make it what? It will convert it to first benzene diazonium chloride, N2 plus and Cl minus. Then when you give water, if you treat it with water, we will get here OH. Okay, so answer will be OH and Br, that is option number A. Okay, next, Hinsberg reagent is 2020 question, very easy question this one. So Hinsberg reagent, if you remember, what is the use of this one? It is used to distinguish between primary, secondary and tertiary amines, right? Primary, secondary and tertiary amines. So if you remember, primary amines, okay, they give us salt which is soluble in alkali, right? Now if you see secondary amines after reacting with Hinsberg reagent gives us salt which is insoluble in alkali. Now tertiary amines, they do not react. Okay, that is how we can distinguish between primary, secondary and tertiary amines using Hinsberg reagent, right? So now if you see, the Hinsberg reagent is nothing but C6H5SO2Cl. If you want to see the structure here, it is like this, C6H5S double bond O, double bond O and then Cl. Okay, so correct answer is option number A here. Now question number 13. If aniline is treated with 1:1 mixture of concentrated HNO3 and concentrated H2SO4, para-nitroaniline and meta-nitroalanine are formed in nearly equal amounts. This is due to. So this is 2019 question. This is again important question, but it is a super easy question if you have learnt this theory. Now what happens generally, if you see, aniline is what? this is aniline, right, and it is a electron donating group, so it should be ortho and para directing, right. But if we do concentration, if we do nitration, we find that even meta product is meta and para products are almost the same. Now what is the reason for that? Now the reason for here is very simple. See, what are the reagents required for nitration? We use concentrated HNO3, right, and we use concentrated H2SO4, right. So there are enough H plus available in the reagent. So being NH2 has a lone pair, so what does it do? It abstracts, or it accepts a proton to form what? NH3 plus. Now once this NH3 plus is formed, now it becomes a electron withdrawing group, and if it is a electron withdrawing group, then meta directing nitro product is formed, right. So the question answer here will be protonation of NH2 group, which causes the deactivation of the benzene ring. That is option number B. Okay. Next, the reaction of benzene disonium chloride with aniline yields a yellow dye. The name of the yellow dye is 2018 question, super easy question. These are your what? Coupling reactions, right? 2 coupling reactions you have studied. So questions have been asked from there also. So if you have benzene disonium chloride, okay, and you treat it with aniline, then we get this product. Okay, so this is called as para amino azobenzene. Okay, option number B. Okay, next question number 15, which of the following is more basic than aniline? So 2018 question, this is also easy question based on the basicity topic. Okay, now more basic than aniline. So if you see, we have aniline like this. Okay, now this is a aromatic ring. So remember, aliphatic amines are more basic than aromatic ring. So here you see, here it is aromatic, here also aromatic, here also aromatic. But if you see benzyl amine, sorry, the structure is like this. Okay, so now what is the reason for this one? Because here the lone pair of the amino group is involved in resonance, right? So that is why it is not available every time for donation, or its availability is less, so basicity is less. But if we see this one, benzyl amine, here this lone pair is not involved in resonance, not involved in resonance, right? So if this is not involved in resonance, then what will happen? This lone pair of electrons are available for donation. Okay, so the correct answer for this question will be option number D. Next, which of the following will be the most stable diazonium salt? 2018 question. Okay, this is the formula given. So this is also easy question based on stability. So if you see, we have C6H5 N2 plus and Cl minus, right? So if this plus is there, we need something to stabilize that should donate electrons, right? So now if you see here, this will donate. So what is the structure of this one? CH3 N2 plus and X minus. This is C6H5 N2 plus and X minus. This is CH3 CH2 N2 plus X minus, and this is C65HCH2 N2 plus and X minus. So if you see here, it is very stable because this can donate electrons by resonance. These will donate electron by inductive effect, right? So that is why these are less stable. The most stable one is your C6H5N2 plus and X minus. So please remember here one point: aliphatic diazonium chlorides are unstable. Okay. Next, Gabriel phthalimide synthesis is used in the preparation of primary amines from phthalimide. Which of the following reagents is not used in the process? 2017 question. This is also very easy question if you have remembered all the steps of Gabriel phthalimide synthesis. So if you remember, we use NaOH, HCl and KOH, but this Hinsberg reagent is not used at all. So correct answer will be option number D here. Next, the correct order of increasing basic nature for the bases in aqueous solution is. So this is a very important question, okay, easy, but you should remember for 2 degree and 1 degree separately, okay. So that is where you can make the mistake in the medium, whether it is given aqueous medium or in the gaseous phase, okay. I will be telling all the orders here, please revise it once again. So first of all, we will talk about gas phase. If it is gas phase, then the order is 3 degree, 2 degree and 1 degree and then ammonia. Whose order I am talking? We are talking about the order of basicity. Okay, basicity order. Now, if the medium is aqueous, okay, aqueous medium is there, then the order has to be 2 degree, 1 degree and 3 degree, then ammonia, okay, if the R group here is methyl group, okay. And the order has to be 2 degree, 3 degree, 1 degree and then ammonia if the R group has to be ethyl group, okay. Now if you see here, we have methyl group. So this is 2 degree, this is 1 degree and then this is ammonia. So we will have first 2, then 1, then ammonia, right. So 2 degree has to be there at the first, so here it is there, here it is there, this 2 we can eliminate. After 2 degree we need 1 degree, that is there, here it is not there, so correct answer has to be option number D, okay. Very easy question, but these orders should be remembered correctly. Next question number 19, the following sequence of the reactions are. So A is giving you on reduction B, B with HNO2 is giving you CH3, CH2, OH. So basically I can say that B must be what? B must be aliphatic benzene disonium chloride, or just let me write it in symbol. So B has to be some R, N2 plus and Cl minus, right. Then sorry, one second, it has to be RNH2, sorry, this has to be RNH2 and this should be something which on reduction can give you RNH2, okay. So there are two things which on reduction can give you NH2, that is your NO2 group and CN group. On reduction gives NH2 group, right. So you can see there is no nitro group, nitromethane is there, yes. Then all are propane nitrile, ethane nitrile and isocyanate. So if we need isocyanate, then we will get a secondary one. So this is, we can eliminate this option. Next thing we need to think about is the number of carbons. Here we have only 2 carbons. Propane nitrile will have 3 carbons, right. So that cannot be there, and nitromethane will have 1 carbon, so that is also incorrect. Ethane nitrile will have 2 carbons and in the question also 2 carbons is required. So the correct answer will be option number B, okay. So now if you see ethane nitrile, it should be like this, then CH3, C triple bond N, this is ethane nitrile. With reduction we will get CH3, CH2, NH2, then with HNO2 we will get CH3, CH2, OH, right. Next 20th question, an organic compound A, okay, on reduction gives compound B. So we have A on reduction gives B, okay, which on reaction with trichloromethane and caustic potash, which on reacting with trichloromethane and caustic potash forms C, okay. The compound C on catalytic reduction, C on reduction, okay, catalytic reduction gives N-methyl benzenamine. So it gives you N-methyl benzenamine. If I draw the structure, it is like this, N-methyl benzenamine, okay. So you can see, so we will go from the backward direction to solve this question, okay, then only we can solve this question easily. So this question was asked in 2016, okay, moderate level question, 30 seconds is enough. Now if you see, first of all, what is that? This is a secondary amine, right. If it is a secondary amine, then this one C must be what? Isocyanate, right. And if it is an isocyanate, and if you remember that this is then what? This is your carbylamine test, right. Then we get a carbylamine test from what? Primary amines, right? So this must be a primary amine, and on reducing this A to B, we are, like I just now told you, two things on reduction can give you amines. What are those two things? One is your nitro group, another is your CN group, right? Now let us see, we have all the nitro groups here. Methanamine will not give you because B is your amine, right? So A has to be what? Either it has to be nitroamines or it has to be CN group should be present, right? CN there is no option, but we need, then here also we have directly benzenamine, so these two we can eliminate. Next, if we see nitrobenzene, so definitely there is a benzene group present, so there is no methane group, so option has to be number A. Let us see now the reaction. If I have nitrobenzene, okay, then I treated it what? On reduction gave me compound B, so I reduced it to give you NH2. Next, what will happen? It reacts with this isomethyl product to give you NC, okay, and then on reduction it gave me what? NH and CH3, right? So correct answer will be option number A. Next, one of the following amides which will not undergo Hofmann bromamide degradation is. So 2015 question, super easy question if you know the condition for Hofmann bromamide degradation reaction. So let us see first of all what is this reaction about. So if you have R C double bond O NH2, okay, and if you react it with Br2 in presence of KOH, this is the reagent for Hofmann bromamide degradation. Then this CO group is removed and we get RNH2. Okay, the condition, what is the condition for this reaction? The condition is we need only primary amides. This is important. What we need? We need only primary amides. Now what do you mean by primary amide? Now see, this is a amide group, okay. So if only one H is replaced with this CO group, then it is primary amide. If we have like this C double bond O, N, H and R, okay, two hydrogens are replaced, then it is secondary amide. If you have like this, then it is tertiary amide. So according to the condition, only the primary amides, this one will give you this Hofmann bromamide degradation reaction. So now if you see here the structure, what is the structure, right? Like let me draw it. CH3, C double bond O, N, H, CH3. So you can see this is not a primary amide, so this one will not react. Next one, if you see, we have CH3, okay, CH2, C double bond O, NH2. Yes, it has both the hydrogens, so it is a primary amide, so this will react. Next one, let us see, CH3, C double bond O, again NH2 is there, so yes, this one will also react. Here if you see, we have C6H5, C double bond O, NH2. So yes, this one will also react. So the question is asking which will not undergo, right? So the correct answer will be what? Then option number A. This will not undergo. Option number A is the correct answer. Next, question number 22. You need to find the sequence of reaction. 2015 question. This is little difficult question. You need to think a bit about the reactions. So first of all is P with bromine and SnHCl. Okay. So we have something as P. Okay. So it is giving you bromination and then SnHCl. Okay. So okay, and if you see the options, these all are nitro, nitro, nitro and toluene is there. Okay, so now if it is nitro and toluene groups are present, so let me try with the first option. Okay, you need to trial and error all the options and it will take a time. That is why we can say it takes, like this question is little difficult mode. Okay, now meta nitro toluene, CH3 and then we have meta nitro toluene. Okay. Next, if you do bromination, now see, according to NO2 group, it should happen in the meta position. So this meta position is blocked. So bromination can take place here. Then what will happen? Okay. Now, then what is happen? SnHCl means what? This will get converted to, sorry, one second. Okay. So this will get converted to NH2 group, Stephan reduction, NH2 group we got. Okay, I'm doing with option number A. Next, what happened? NaNO2HCl, that is benzene disonium chloride. So this one will give you N2 plus and Cl minus. Okay, now this one is what many of you might not be knowing what is the role of this one. H2O in presence of H3PO2 adds H plus in this group, means this whole group will be removed and H will be added. So what will happen here? This whole group will be removed and I will be getting H here. Okay. Next, KMnO4 will convert this CH3 to COOH. So the option A if I take, then the product I will be getting is COOH, and at meta position I will be getting bromine group, right? But that is not the answer, right? We need that they should be what? Together, they should be adjacent to each other, and that will happen only if we take what? Ortho, or let us see if we are we getting if we take ortho. Let us check with the option number C and D, because we have ortho here. First of all, ortho nitrotoluene. Okay, so if I have ortho nitrotoluene. Okay, now you have seen what is happening to this NO2. First NO2 gets converted to NH2, then N2 plus Cl minus, and then it will come to this one, right? So this one will become H anyway, but I will do it step by step. Wait. So first we are doing bromination. So bromination will add at the meta position, Br group will be added here, right? Either here or here, because here you can say there will be more steric hindrance, so this will be the more favorable position. Now this NO2 group will be converted to what? First it will be converted to NH2, then N2 plus Cl minus, and finally H. So we will get this one, and then this group will be converted to COH group. We will get para position. So that is why this one is not answered, this one is not answered. Bromotoluene will not work because we need nitro group at any condition. So it has no nitro group. So that's why we can eliminate option number D as well. Okay. So what is left? Let us try with the para nitroaniline. So you have NO2 group and CH3 group. Okay. Now if you do what? Bromination. Bromination will add meta position here, and this one is also ortho position. So we will get NO2, here Br, and here CH3. Okay. Now once you treat it with NaNO2HCl, and once you treat it with SnHCl, this will get converted to NH2, right? After that what will happen? We will get this one will become H, here I will get bromine, and here I will get CH3. Okay. Then once you treat it with KMnO4, we will get the required product. Okay. So the correct answer here will be para nitroaniline, option number B. Next, question number 23. Again a reaction based question, 2015 question. This is also simple question, but you should be knowing about the nomenclature, because nomenclature of amines are not direct, like little different, you need to put N and all. So that all rules should be known to you. Otherwise reaction wise it is very easy. So alcoholic AgCN, 2-bromopropane is there. AgCN will add NC, right? Isocyanate will form. So this is your X. Now if I do lithium aluminium hydride, what I will get? Here I will get NCH3, and this is NH, right? So what I'll first will be N-methyl. So this is wrong, this is wrong. Next, N-methyl propane 2-amine, right? So this is at the second position, 1, 2, 3. So N-methyl propane 2-amine is the correct IUPAC name. That is option number B. Okay. Okay. Next, coming to question number 24. An aromatic compound A, C7H9N, on reacting with NaNO2HCl at 0 degrees Celsius forms benzyl alcohol and nitrogen gas. The number of isomers possible for compound A is. This is 2014 question, easy question. You should be knowing to draw all the different types of isomers. First of all, we have, remember, whenever the number of carbons is more than 6, there is a benzene ring, you should think. Okay. So first of all, you can then easily think that this must be CH2NH2. We can draw like this. Why I am telling? Because on NaNO2HCl it is giving you benzyl alcohol. If you directly put NH2 here, then it will give you benzene disonium chloride, right? But we are getting an alcohol group, so that means this has to be what? This has to be CH2OH, right? the number of isomers possible for this one, right? The number of isomers possible for compound A. So this is one we can draw. So this is one of the isomer that we have seen. Next we can draw like this. See, we'll take NH2 here and I'll add CH3 here, right? Done. Next what we can do? Next we can put this in different positions. This is meta ortho position, then I can put it in the meta position, and I can put it in the ortho position as well, right? So we got 1, 2, 3 and 4. We can, one more thing we can do is we can convert it into secondary amine group like this, right? N. Okay, so total number of isomers is 5, so correct answer is option number A here. Next, the correct sequence of reactions to be performed to convert benzene to bromoaniline. We need benzene to bromoaniline, to meta-bromoaniline, okay, meta-bromoaniline. Okay, this question was asked in 2014. It is a very reaction easy question, but directing nature you should be knowing, which is ortho-directing and which is para-directing, meta-directing, that sense should be there. Now if you see, first of all I'll do nitration, okay, so I'll do option number A I am solving now. If I do nitration, what will I get? First I will get NO2, okay. Then what is there? Reduction. So if I do reduction, this NO2 will be converted to NH2, right? And then if you do bromine, you should know that NH2 is an electron donating group, right? So bromine will go to either ortho or para position. So we will get this one, or we can get this one, two separate products, but definitely we will not get meta-bromo product, right? So that is why we, so that is why we can say that option A is incorrect, okay. So I can say option A is incorrect because we will be getting here what? We'll be getting ortho and para bromination. Now let us see the second one. First you will do bromination, okay. So first I did, so I am now solving option number B. First I did bromination, anywhere I just added. Then I did nitration, okay. So bromination, if you remember, they are electron withdrawing groups, but they are ortho para directing. So bromination, after that if I do nitration, NO2 will come here, and then if I do reduction, what will happen? After that if I do reduction, I will be getting NH2. So this is also not giving me the required product, so that is why B is also incorrect, okay. So option number B is also incorrect, so I cannot take that as well. Now let us see the next option which we have. Nitration. So first if I do nitration, okay, done. Then bromination. So NO2 group is a electron withdrawing group, meta directing group. So bromination, bromine will come here, and then you do reduction. So this NO2 group will be converted to NH2 and bromine, right? So now if you see, this is what the question has asked. So the correct answer for this question will be option number C, okay. Next, again, the reaction is given, the product is given to you, P is, you need to find the reactant, okay. So let us see this question. First of all, dilute NaOH and heating is done. So that confirms that this must be an aldol condensation. If it is an aldol condensation, then R has to be either an aldehyde group or a ketone group, right? R can be either aldehyde or ketone group. Next, what happens here? There is a Grignard reagent and the reaction is happening. Now you see, we will not be getting an aldehyde or ketone if we react, like the reactant must not be aldehyde or ketone, because the product is aldehyde or ketones, and the P cannot be aldehyde or ketone, right? So you can see option number A is already a ketone, we can eliminate this one. This is also a aldehyde already, we can eliminate this one, okay. Now if you see, amine and nitrile is there. Now we do not have any reaction of amine with Grignard reagent. Do we have any reaction like this? RNH2 and RMGX, right? This reaction we haven't studied, this is not there, but again, now let us, but we can have something with these two, but we'll try with these two, okay. So first let us try with ethane nitrile. So if I try with ethane nitrile, CH3 C triple bond N, okay. Next CH3 MgBr is added, so this is minus, this is plus, so this is plus and this is minus, so CH3 will be added to this one and this one will be added here. So what will I get now? One bond will break and we will get CH3 and MgBr. Then what will happen? Hydrolysis will take place, and once the hydrolysis takes place, we will get here what? Here we can get a oxygen group, that is a ketone group will form. Now if this one is undergoing aldol condensation, then what will be the product? Let me see. I have taught you how to draw the products by a trick. Just write both the reactants vertically, okay. Then what you need to do? You need to connect this one to this one and remove one hydrogen here, add one hydrogen here, and then erase this bond, okay. And so now if I do this one, then what will I getting here? One second. Yeah, what will be the product formed here? So the product will be CH3, I am writing here 1, then this carbon COH, okay. Then to this carbon we have one more CH3, okay. Then third carbon, that is CH2, okay. Fourth carbon C double bond O, then fifth carbon CH3. Now what will happen? There will be dehydration because heating is also given. So most stable alkene will form. So here what we will get? A double bond, okay. So now if you see the name, we have 1, 2, 3, 4 methyl. So I can number it like this: 1, 2, 3, 4 and 5, right? So 4 methyl pent 3En 2ONe, okay. So the correct answer will be, obviously we have got ethane nitrile, option number C, okay. Next, biologically active adrenaline and ephedrine used to increase the blood pressure contained. So 2024 question, I will mark this question as difficult because generally we do not study the uses of amines in there. So in that section this is there. So here you should remember it contains secondary amino group, that is option number B, okay. Next question was also asked in 2024, a reaction based question. This is a simple question. Aniline is there, NaNO2 and this one will give you benzene disonium chloride, right? And then if you treat it with phenol, so we will get what? Coupling reaction will happen. We will get something like this, okay. So this is what? Para-hydroxyazobenzene, that is option number C, okay. Fine. So next question number 29. Given below are two statements. This is very important question. Okay, this is not a KCET question, but this is a previous year NEET question, okay. But I saw this type of questions are somewhat related, so given a question in that form also. Now see, primary aliphatic amines react with HNO2 to give unstable diazonium salts. We have learnt that if you take primary amines and treat it with HNO2, okay, we get alcohols. Now why are these alcohols formed, whereas in case of aryl amines we get benzene diazonium chloride? That is because the primary aliphatic amines give you unstable diazonium salt, that is why they get converted to alcohols. So this statement is correct. Next, primary aromatic amines react with HNO2 to form diazonium salts which are stable even above 300 Kelvin. Up to this statement was correct, okay, but they are not stable above 300 K. They are stable up to 300 K, or you can say below 300 K. Above 300 K, even benzene diazonium chlorides are unstable, okay. So that is why this statement is not correct. So what is the answer? Statement 1 is correct, but statement 2 is incorrect, option number A, okay. So these basic details while studying NCERT, please keep in mind. Okay, next question we have this one, again a reaction based question. So this is also not a PYQ, I have just included it. So first of all, LiLH4 and H2 if you take, we will get what? We will get CH2NH2, right? Reduction has happened. Then if you do NaNO2 and HCl, since this is a primary amine, what will I get? I will be getting CH2OH, okay. The correct answer here will be option number B, okay. Fine. So Yes students, so these were the 30 questions of amine groups that we have practiced. These were some of the previous questions. So now you can practice similar questions. You can see more questions are there on the reactions of amines. So practice all the reactions of amines again and again. The test of amines, basicity order is a very most probable topic. Okay, so please make questions according to these topics. Okay, so I hope this video was helpful and you have learned some of the concepts, you have revised the concepts, and if you found this was somewhere helpful for you, then please do not forget to subscribe the channel. Okay, thank you for watching and see you soon in the next episode, and do not forget your target 60 out of 60. Okay, thank you.